Something to keep in mind with this derivative function is that the derivative as a function, at each point of the at each x value, the value of the derivative tells you the slope of the tangent line at that function. And that means that the shape of the graph of the derivative has a close relationship to the shape of the graph of the original function. To see how this works, let's look at the graph of natural log x. So here's a graph of natural log x. I've intentionally not labeled the axes here because the geometry that I'm getting at is it's not really about specific values. It's more about sort of the general trend of how things work. So we don't need particular x and y values to get at what I want to talk about. So let's sketch the graph of the derivative. Now remember, the derivative, so f prime of x, is the slope of the tangent line at x, right? And different x values will give us different tangent lines. So different x values will give us different slopes, right? That's why the derivative is a function of x. So to sketch some values for this derivative, what we'll have to do is pick some x values and approximate what the slope of the tangent line will be at those x values. For example, let's start with this x value way off to the right. It looks like if we look at the graph of natural log and think about the slope of the tangent line here, this slope is positive, but it's pretty small. So the graph of the derivative would be, right, the height of the derivative is small. Right? So remember, the slope on the graph of f is the height of the graph of f prime, right? So since the slope of this tangent line is positive and small, the height of this point is positive and small. Okay, well, let's move over to a different x value. How about here? So now the slope of the tangent line looks like this. It's still a small positive slope, but it is a little bit bigger than the first one that we did. So the height of the derivative graph at this point should still be positive and small, but a little bit bigger than the one over here. So maybe like this. All right, let's jump all the way to this x value. Here, the slope of the tangent line looks like this. So this is positive, but it's getting kind of substantial now. So the height of the derivative graph is the slope of this line. This line is positive and sort of, I don't know, medium. Right? We can't tell exactly what the slope is without having some labels on our axes, but the slope of this line is sort of positive and medium-sized, so the height of the derivative is positive and kind of medium, so maybe like this. Of course, at all of the intermediate x values, there are tangent lines there as well. We can't draw them all just because there are infinitely many of them, but we can kind of estimate the trend, right? As we move from this point on the left rightwards towards this point in the middle here, the slopes of the tangent lines are all positive but getting smaller. So the height of the derivative graph should be positive but getting smaller. So like this. And same thing over here. All right, well, we can move even further to the left than this x value. We could choose this x value here. The corresponding tangent line on the graph of f is here, right? Now the slope of this tangent line is positive and quite large, so the corresponding point on the derivative should have a height that is positive and quite large. So now we're way up here. And we could get even closer to x equals 0 here. That would put us down here. And the slope and the tangent line here is going to look something like this. This slope is even larger than the last one that we did. So the height of the derivative should be even higher, so way up here. And again, as we start at this left-hand point and move rightwards, the slopes are all positive but getting smaller. So if we fill in the gaps, it's going to look like this. So this right here, this is a sketch of the graph of the derivative function. f of x, right? And this, or f prime of x, and this graph is f of x. All right, so you can see just by kind of estimating what the slopes look like, you can get some idea of what the graph of the derivative function looks like. It's actually a lot of work to actually sketch all of these tangent lines and plot points individually. What I do if I want to have some idea of what a derivative looks like is I just imagine a tangent line here, right, and mentally think, okay, so that's a positive large, so up here, and then I just mentally slide this tangent line rightwards, right, or I slide its tangent point rightwards. So as it slides rightwards, what happens to its slope? Well, it looks like the slope is getting smaller and smaller, and so the derivative should come down like this. Let's look at another example of sketching a derivative graph just based on the graph of a function. So here's a function. Let's sketch its derivative. Again, we can't be too precise because we don't have any x or y values scale labeled on our axes, but we can still draw the general trends. Let me also extend this y-axis downwards. Okay, so all the way to the left, it looks like at this spot, the tangent line is going to have a positive slope, but it's a pretty small positive slope. So let's start our derivative with a small positive height. Remember, the slope of each tangent line will be the height of the derivative graph at that x value. Now as we move rightwards, these tangent lines they all have positive slope, but the slope is increasing, and it looks like we're heading towards a slope of, I don't know, some medium value. So maybe we're heading to some medium value, so say here. So maybe it goes up like this. Now, at this x value right here, there's a jump in the graph, and it's kind of hard to know what that is going to do to the derivatives. So let's just leave a hole in this graph. And later we'll come back to the question of what happens at a discontinuity like this. All right, now for this next piece of the graph, it looks like the derivative here is the slope of these tangent lines are negative and kind of big, but as we move further to the right, the slope is getting closer to 0. So the derivative, the height of the derivative, should be negative and kind of big, so maybe down here, but getting smaller as we head to the right. Okay. And again, at this point, there's a jump in the graph, and it's not clear what happens at the jump, so let's not commit ourselves to a value. But it looks like the slope that all of these tangent lines are heading toward is 0. So it looks like the height of the derivative should be heading towards 0, like that. Now immediately to the right on this next piece of the graph, these tangent lines, they have negative slope, and this negative slope is quite large. So it looks like the height of the derivative should be negative and large, so it's going to jump way down here, and these tangent lines are getting less steep as we move to the right, so our derivative should start out negative and large and then get smaller. But it looks like these tangent lines aren't actually ever becoming horizontal, so their slope isn't becoming 0, so although the slope is getting smaller, it doesn't actually get to 0. Now there's a hole in the graph here, so we should probably leave a hole there. Okay, so there's a sketch of the derivative of this function.